Cool.
You are good.
Do they have audio?
Check. Test. Yes.
Sounds like they do. All right. Hi. My name's Tad. I go by Phaedrix. That's my introduction. Okay. So to start off with, I'm going to do some totally contrived code examples. And we're going to pretend that you're writing a game. And this game has 3 models to start with, 3 classes. You've got a player. And as that player, you can go to different locations. And you can mark those locations with your team color. So here's some simple classes to capture what?
You changed it.
No, it's coming. It's coming. So here's some simple classes to capture those parts of the game. Players have an ID, a unique ID to figure out which player's who. Your location is an X and Y coordinate, and your team color is some combination of red, green, and blue to make RGB, whatever. And in your code, you're like, okay, I got to compare and figure out if these players are the same. And you find yourself doing it all over the place. And for a player, like to see if player 1 is the same as player 2, you can just compare their IDs. Okay, cool, right? For location, it's a little more involved. You got to make sure the X coordinate is the same, and you got to figure out the Y coordinate is the same. You're like, all right. But then when it comes to team color, you have to compare the red value, you have to compare the green value, and you have to compare the blue value. And you're doing this all over in your code, and it makes you start to think, man, I'm doing Ruby. I should just write my own comparison operator for each of these classes, right? And that way, sorry, maybe I'm kind of blazing quickly, but I realize there's some people who are fairly new to Ruby. I'm going to slow down a little bit. So in Ruby, you can define your own operators for your classes. In this case, I am defining double equals comparison operator, and I'm just saying, is the other whatever, hopefully a player, the same as me? And by doing that, I'm just taking what I was doing before and putting it into a method. And so I'm saying my ID versus the other entity's ID. If they're the same, I'm going to say I am the same.
So you do have trouble if it's not a player.
Yes, I'll account for that in later code. But that's a great point that Alan brings up is I'm not checking to make sure other is player as well. It could be a weird bug that I have some other entity in my system that has an ID, and somehow their IDs match, and I'd say, yeah, they're the same, but they're totally not the same, right? So for my class location, I've got to do the same thing I was doing before in that method. I've got to say, okay, my X has to be the same as the other entity's X, and my Y has to be the same as the other entity's Y. Team color, same pattern. I've got to make sure my red value is the same, my green value is the same, and my blue value is the same. Seems pretty straightforward. I just basically took what I was doing already, put it into some methods, and then when I do my comparisons, I don't have to stop and think about matching up all the different attributes. I can just compare the 2 things directly and say, hey, is player 1 the same as player 2? Yeah, because I'm matching their IDs. Is location 1 the same as location 2? Yes, their X's and their Y's are the same, and so on with team color. And you're like, awesome, that kind of moved my code into a better place. Now I don't have to think about it every time I do a comparison. Seems pretty good. And then, you're coding along, and it was interesting because I was talking to my manager today, and he's like, you should write a blog and write some blog posts. And I'm actually like, you know what? I've actually written code for in 3 different styles this year. I did a blog in Jekyll, and then I decided to do one in Ruby on Rails. And then I decided recently to redo it again in Gatsby, because I'm like, writing blog posts is kind of hard and boring. But writing the code for potentially writing a blog post seems really fun. So I kind of think of that as procrastination code. you do the fun, cool side thing because the big thing is kind of gnarly and boring or something. So let's say in your game you come across some big, gnarly, boring something that you want to do, and you're like, wait a second, way back when I was doing that, doing those comparison operators for my different classes, I think I noticed a pattern, right? What I'm doing is I'm comparing attributes and I'm matching them up, and I'm just saying, are all these attributes the same? And if all the attributes that I care about are the same, then it is the same thing, right? So can you kind of see when I line them up pattern to this? Sure, right? So you're like, sweet, that's a great place to refactor. So you decide to refactor it out into a module, call it comparinator because you're a fan of, Phineas and Ferb, and there you go. It's great because all your code has been moved into a module out of your classes, and it's a great refactor. And here's, of course, what your module looks like, which is terrible because it's not really doing anything at all, right? You're still saying, okay, I'm doing conditional on the class, but I'm not really gaining anything by moving it to a module. I was just fooling myself. You're like, Actually, I'm kind of going fast through this. If any of you want me to stop on any of the code or even pull up a pry and like demonstrate anything, like stop me. I'm totally happy to if I'm going a little too fast. Okay. So this refactor is pretty lame. You're like, it seems like there should be a better way to do this. So maybe I'm going to try again. So there's the kind of tricky things in this refactor are there are a variable number of attributes to compare, right? Player has one attribute, ID. Location has 2 attributes, and team color has 3 attributes. So even though they're all comparisons, I've got a variable number of attributes that I'm comparing. But, if I had a method that took a variable number of arguments, that probably wouldn't be a problem. What's that? Yeah. And you're like, well, player has ID, and location has X and Y, and team color has red, green, and blue. Those are all different names, right? Like, how am I supposed to handle the different names of the attributes? And you're like, well, we've got a handy method called send, where you just pass in the name of something, and it just calls whatever you want, right? And so the things I'm calling can be a variable. And the last one is the methods are all defined slightly differently, right? Like they're I'm defining one method one way, one method a little bit different, and a little bit different. So, but their pattern is the same. So if I dynamically define a method using the same pattern, then that might work. So, okay, with these 3 things in mind, let's try again. So here's my second attempt at a comparinator module. And it's going to take a method, or I'm going to have a method for it called define comparison. And it's going to take a variable number of attributes. And just to be on the safe side, I don't necessarily have to, but I'm going to say, I want to make sure all these attributes are unique, so I'm not doing something weird. And I'm going to define the double equals method, and that's going to take a block, which is basically just the body of my method. Are you guys familiar with this kind of stuff? Okay, I'm seeing some head nods. If I need to explain anything, this is a little bit meta, so I know not everybody has seen this kind of stuff. So, right, like Alan pointed out, if this is not the same thing as me, false. I'm not gonna mess around. If you're something different than me, I automatically know we don't match, right? We're not the same. Yeah, my code, you know, if your team color is not the same as my team color, right? Okay, so, and then I can say attributes all and loop through the attributes, and I can say, what does attributes all question mark do? Do you know, or are you just setting me up for a question? Okay, so attributes all is if everything in the collection returns true, or everything in the block, okay, I iterate through a collection. If everything I yield to the block returns a true, then it's overall true.
So it maps all the values and evaluates true.
Yeah, so if this expression inside the block is true for every single attribute, then it's going to be, it returns true. But if any of them are false, then the whole thing is false.
So it's doing an each and return and breaking with a false if nothing, if the
Right.
individual piece is not true.
Yeah, it iterates through if any.
What? Yes. Okay.
Yeah.
I just never seen that syntax. So
Yeah. No, great question. Thank you for asking. So how are you feeling about this code? Does it do what I was kind of proposing, where it's taking the variable number of attributes and it's doing my comparisons for me, and it's going to return true, and it's going to define that method on anything that I call define comparison with, right?
How do you use it in class where you include the module?
Oh, what a great question, right? So now I can say for my class player, it's got an attribute of ID, and I'll have to pay you after for your great questions of setting things up. And so, you know, I extend comparinator, and then so when I extend, that makes this a class method, right? Not an instance method, as opposed to include. And so I can call that on the class level, define comparison ID, and it will go through and define a method for me, right? Class location. I say,
extend works at the class level and include works at the instance level.
yeah. So my attribute reader X and Y, I extend my comparinator module, and then I can define comparison X and Y, which gives me X and Y attributes, goes through, defines a method using X and Y. And my class team color, you know, I have my attributes, I extend comparinator, I define comparison red, green, and blue, right? And I check to see that it works, and guess what? It works. It's just the same as before, only now I actually have a module that doesn't have to worry about what class you are and swap and switch, you know, do a switch case statement between those. It actually is a general purpose type module, right? Yep, my test pass again. Thumbs up, that's awesome. But then one thing that's kind of annoying, not super terrible, but I decide I want to augment that comparison operator in one of my classes. And I want some super stupid, simple logging. And so I'm like, oh yeah, whenever it does a comparison, I want it to let me know that I'm doing a comparison. And so I throw this code together and I'm like, yeah, this is gonna work great. But as soon as it hits that super, fail. Are you gonna explain it? Do you wanna explain why? Right. So,
well, it's also
so define comparison defines the method on class location. Right. And then if I try to define it again, it's going to clobber the
Oh, there's no super.
Yeah, it's just going to clobber it. There's no super to call to. It's just going to say like,
Because it's not an
right. It's not in my ancestor chain anywhere. It's just kind of there, right?
Well,
Yes.
if you included it, wouldn't it find it?
Well, when I say define comparison, it's defining method on itself, right? So it's doing a define method for a class location.
Right.
And so class location is like, oh, thanks, I defined a method. And then the next line, you're saying define the same method. And it's like, oh, I'll define that same method again. But then no super to call, because
But had you done include instead of extend, then that would have worked.
no, it's not in your ancestor chain.
defined method.
It's you're creating it right into the class, not on something you're.
So do you make a base class?
We'll find out. Let's find out.
Yes.
It will become an instance method in the class that it. On location, right? Because you're calling the define method. Yeah, we'll clobber whatever comes before it.
Yes.
Right.
Just overriding it is what you're saying.
Starts reaching up to super.
And there's no
super
no
because-
ancestor, because it's my. What's that? It
No, because
might.
it'll do an instance.
Actually, it might. There.
It would be comparing-
I think you're right. It would. There might be something it finds, but it's definitely not what you want. And so. Okay. So, does everyone understand why the fail? WTF? Why the fail? Okay.
Yes.
All right. But you happen to be looking around at Ruby modules and you learn some interesting knowledge that not a lot of people know. And in Ruby, modules, lowercase m, are actually instances of module, or they can be. And when you create a module.new, you can pass it a block, which is interesting. And if you say module, what are you? It will say, I'm a class. You're like, really? So I can inherit from you? And it will say, you sure can. So you could do something like this, right? My mod is module.new. Neat.
Solved.
Neat. And I can say, my mod is a module.new. I can have a class, and I can say, hey, foo, include that module. And foo will say, thanks for that module. I'll include it right now. And you can have a module named egget.
There it is.
And you can define a method last. Oh, dang it. Why did my slides? Oh, why does Keynote keeps upcasing my ands, and it drove me nuts. Yeah, so in my module of egget, I can define with last name, and I'm saying, okay, whatever I am plus space egget. And so my name equals Ben, name.extend egget, and name with last name gives me Ben space egget. Right? I think this is pretty common Ruby-ish code that you, maybe the fact that I'm doing it on a string and I'm extending the instance of a string is a little weird, but Yeah. So I will show you this code, which is, look at that, almost identical. But in this case, I'm calling module.new, do, and I'm defining a method within my block for that module. I set it to Thorley. I say name equals tad, name.extend Thorley, name with last name is tad space Thorley. So are you convinced that these are equivalent? That's true. This one is anonymous, this one is not, right?
Because you're doing the assignment on module 2.
Right. So if later on, if I try to do something with egget, it will be like, oh no, that's a constant. Don't do that.
Don't even try.
Why are you messing with egget? Don't do it,
Wasting your time.
right?
Yeah, baby.
But this, if I say Thorley equals some other thing, Ruby's like, okay, it's a new thing now, right? That it's just a variable. It's not anything.
Inspected ancestor chain.
Right. And the other one would be an anonymous module, right? Exactly. That's a great point. So what if I do this? I make a class of last name, and I inherit from module. And in that initialize for module new or last name.new, I define a method of full name, and I say, hey, full name is name space last name. And then I have a class named Alan, because what a great name for a class. And I include last name dot new Maxwell, and I give it a name so my last name class doesn't get confused. And I say Alan equals Alan dot new. I can say Alan dot full name is Alan space Maxwell. What do you think about that? Because this is a great slide to have a discussion if you guys.
How is this useful?
What does this get us? Nothing much yet. But let's say I have I take that same last name module and I initialize it with last name. I keep that last name variable around, and I decide, maybe I want to also define an inspect. So whenever this thing comes up, like an ancestor chain or something, it will tell me a little bit something about itself. So now, like the exact same thing as I was doing in the module before, I have a class Alan, I include last name, new mod, Maxwell, da 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 da. But when I ask Alan about his ancestors, he says, well, there's me, and then there's this great class last name, and Maxwell is the thing that I'm using, is the configuration that was passed into me.
Is the implementation of inspect.
Yeah. So it's when you say inspect, it's just like, which I think is kind of handy, right? Kind of interesting. So taking that module-ness that we've just played around with, let's take those ideas and apply it to our first problem. So I've got my third iteration, class comparinator, inherits from module. I initialize with some attributes. The code looks pretty much the same. I decide to do an inspect, and that's pretty much similar to what the inspect I was doing before. And now, when I do my classes, I can say, when I include comparinator, I don't have to do a separate method call. I can just do it straight up with the attributes that I'm passing. right? So,
Oh, because they're in initialization.
right, should I back up and, because this is a great slide to stop and have a conversation if you want.
Yeah. I'm still kind of hung up on extending and including are quite different. Because extend is no different than like me defining the same method twice and the bottom one wins.
Right,
Extend just
Because
extends everything.
It's
right there.
overriding.
right.
But including
But
is absolutely including it in the ancestry
But
chain
it's
too.
isn't it including at the time it's instantiated as opposed to
Doesn't
when
matter.
it's defined?
So comparator was in this ancestor chain. It's just that's not what the method is defined.
right,
The method that was defined in comparator
In class.
was the filter.
Right.
The actual method that super find a runtime.
and
Right,
so
my point there
now,
is had he included, not extended, he could have done the super example just fine.
It doesn't exist. It's
There is no super because
Alright, anyway, I'll come back to that later.
okay,
Anyway,
If you're
working.
succeeding with the double equals, it's because there is. That's just.
it's not the double equals you expect, I don't think.
it's returning exactly what I put in there, yeah.
double equals is probably a bad example just because of that.
Yeah,
Anyway, but go on, I don't want to
so
put
in this
Darn it.
case, I can just say include comparinator. I don't have to call an additional method for setup. And this does show up in my ancestry chain, and the comparinator module that I'm creating is where that define method is happening. So
if you want to override the double equals in location now,
it will work.
well,
Yes.
because comparinator is now part of the ancestor chain, super exists.
Yes.
Is that what you're saying?
Right. Yes. That's exactly what I'm saying. So sometimes in the wild, I see people, like this is just a thing I've recently come across in the last few months. Sometimes people like to do bracket, redefine bracket, and all they're doing is just essentially calling new. So I'm doing that here, and that lets me do this maybe more stylish syntax, right?
Say that
So-
again? You lost me.
Okay, so I've got this, right? I can define, the bracket operator, which takes args, and I just directly call new, and then I can actually,
Go back over just a second.
okay,
For new args. All right.
so instead of calling comparinator.new ID, I can do include comparinator ID. And this is, well, it's not technically an array, I'm overriding it. I've seen this kind of thing happening with this pattern. So I just thought I'd throw this in to say,
It's just syntactic sugar.
hey, yeah, like what you're really doing is this, but people throw in a little bit of fancy syntax to do something like this. So that so it looks, it's you might, if you stopped and thought about it a lot, you'd be like, wait, what's going on? But this doesn't look unfamiliar, and you're like, okay, yeah, that looks Ruby-ish, and I kind of get what it's trying to do, right? And
You just want to decide whether .new is more readable to you.
then yeah, right? So, like we were talking about before, now I can do this, and super works just fine, right? So, what did we end up with?
Did you get it?
Instead of
It's a little further along.
code that isn't, instead of code that's in a few other classes, you've kind of moved this comparison stuff into one place, and it's in a pretty nice module. And so it's encapsulated as try. you know, whenever you put it in a module, you're kind of thinking, oh, maybe I'm going to reuse this again sometime. So if I came up with the fourth class, I want to define a comparison operator, you know, include comparator, some brackets, throw in some attributes that I want to use to make sure that they're the same thing, and I'm good, right? What I think is really interesting about this pattern is that it's generating code based on some things I'm passing in, right? I've got a pattern, but the pattern needs a little bit of information, and so I can pass that information in, and then it's just generating the appropriate code for me, which I think is kind of interesting. You know, and now I've got code that shares some information about itself, like with an inspect, or you know, I can maybe do some other things in that class that that I created that will tell me a little bit about itself. I think that's kind of interesting.
It's not bad.
And the other interesting thing that I thought was interesting about this is regularly you never include the same module in your class twice, right? Like, why would you? What's the point? But what if I did something like this? I decide I want a class and I'm going to call it Watcher, and I say, okay, if you give me a method name and a method before the thing gets called and a message after the thing gets called, I'm going to create a method that you know, outputs your enter message, and you know, outputs your result, and outputs your exit message, and then returns the result, right? So if I have a class chatty string, I can inherit that from string. I can include this watcher 2 times and watch 2 different methods on that string. I can say, okay, whenever you call 2s on that method, give me an enter 2s message, output the value, and then give me an exit 2s, right? And when you call 2i on me, I want you to say hello, whatever, and goodbye. So I make a new chatty string, and I call 2s on that chatty string, and you know, I get the appropriate messages: enter, you know, value, exit. And I call 2i, I get hello, value, goodbye. And when I ask chatty string, who are your ancestors? You know, chatty string could tell me, oh, I'm a chatty string and I've got 2 watchers. And if I, you know, there's a lot of code to put on one slide, but so I didn't do all of it. But you know, I could also have an inspect, and so when I'm looking around at this thing, I'm like, oh, I've got a watcher that is watching 2s, and I've got a watcher that's watching 2i, which I think is kind of interesting.
So in the define method, you've got method name do, and then args. Args is going to be the list of parameters, that whole list, right?
It's going to be whatever.
And doing that in the include statements. What is block? Where's block?
That's just standard define method. If I want to just be, yeah, and in fact, define method requires you to say args and block. You can't just say super bare in a define method. You have to actually say super and give it something. So that's just saying any type of method, whatever arguments, whatever block I get, I'm just gonna super that. Is that? It just means,
even if blocks non-existent.
yeah, I might not get a block, but it's whatever this method does, whatever parameters this thing might possibly take.
Is block a name?
It's a
It's just-
function of what define takes for it.
It's just the block. It's just the name of the block that.
Block itself, the word block doesn't. I think it's just.
It represents the basically whatever's in the block that you pass a method. Like if I wanted to do something with the, like I wanted to call or yield, or I can't remember exactly, the block, then I could do something with it, right? I think it can be anything. Yeah. Yeah. This is,
That's the alternate.
yes.
It turns the block. And when he uses it again on the old line, it's actually converting it back to a block. It's taking the prop and converting it back to a block, so that it's a super receives a block. Also,
Right.
I'm running out of stuff with business logic, by the way. Any of this is like blowing.
This is meta. This is not.
This is like writing bells or libraries like bells.
Right. Yeah. So to answer your question, yes, you can name it whatever, but like Matt's saying, the ampersand is.
But I like it.
I know block is just the standard name that people are giving it, but banana sounds awesome. Yeah, it goes last and it has an ampersand.
So because he's defining method, this is not going to be receiving a block.
Yeah, you just say, I recognize a block could be possible, but I'm not going to use it.
So let me ask this.
Right.
In your initialize, you're naming, method name is the first variable, that's 2s or 2l.
Right.
Message is a name parameter, exit message is a name
Mm-hmm.
that you've included in your new. Block in this case is nil. Is that right? Because there's no block being passed in.
Yeah, when I call string to s, I'm not giving it a block.
Right. So if you were to do string to s, do, and then something else, then you would be passing this block. That is what you get.
Right. Yeah.
Super would like
Super would
Right.
like.
It would be,
I'm 2s. I'm simple. Why are you giving me a block?
What his next line, watch it on here. It's dynamic method building is ready.
Right. Yeah. Like I could watch an each, or I could watch a map, or I could, something that does take a block, and it would give me my messages. Do I need to explain more?
We'll do exactly nothing up to us is the point. Because it to us doesn't look.
but that's that. If we're not using 2s,
This meta programming is just smart because it allows you to override other methods.
It's a general purpose, right? It's a general purpose. If you're a method that takes a block, if you're a method that doesn't take a block, if you're a method that has a bunch of arguments, if you're a block or a method that has a bunch of arguments, a method that only has one argument or 0 arguments, it doesn't matter. This code works across any method, right? It's mostly about
in the case of 2s and 2i, block is your better.
exactly, yeah.
But if we were using,
If I wasn't doing a string, I think string might actually have an each. And it goes across the characters. Yeah, each character, maybe. This is the kind of stuff I rarely do and look up. But anyway, the point is I can use this multiple times in the same class, and it will build different functionality for me. An example I was looking at, actually, so if you want to look at a fully formed example of something that does double equals and a bunch of other stuff, there's actually, if you've heard of DRUG, they have a dry equalizer module that you can look at, and I've got the link there. A lot of this information is also in a great blog post and he calls it the module builder pattern, and that's probably what you'll hear it called if you're looking around lately at blogs and stuff. I thought this one was probably the best explanation. He goes through, he actually builds one that's a dynamic adder of different things, and I think that's really interesting. One of the examples he gives is something that catches method calls. So it intercepts method missing if it fits certain criteria, matches certain patterns, right? So you're like, okay, if anyone tries to call certain patterns on this class, I'm going to catch it with.
So like using the regex.
Exactly, yeah. So if they call find underscore something, right? I want to catch that and run this block with find type operations.
So kind of like the old
Something like that, sure. And then in that same class, I can say, well, if they're trying to catch, or if they're trying to call some kind of like iteration something, right? Then I can catch that and figure out and do some iteration. So he just wrote a general purpose module that catches method names based on a regex pattern, and then handles them with whatever block you pass to it. And he can use that multiple times in the same class. And it, he's like, okay, do you match the pattern? If not, super. And, that goes to actual method missing or blows up or whatever. But, he can have multiple interceptors in his class. And when he calls ancestors or whatever on that class, he can see, oh, it's me, my method catcher catching this pattern, my method catcher catching this pattern, and so on, right? I think this pattern is really interesting. I think it's maybe not something you're going to be like, oh, yes, I totally love that pattern. I'm going to refactor all my code to use this pattern, right? This is a fairly more special purpose pattern, I think. But I think it's fun to have in your Ruby toolbox, right? Like to say, oh, I recognize there's this pattern in my code, but I don't want to write a bunch of different modules to handle all the different variations on this pattern. But it would work great if I could just pass a little bit of information in and have it create it for me. Like it's if there's it takes your module and makes it a little more general purpose and can do kind of a more general pattern than your typical module usage
So to test
uses.
you definitely have to be writing tests against the class that is included in the module. So because the module itself is too generic. So you have to actually make sure that
Yeah,
your
or
class is doing
just shove it in a dummy class and test it, right?
No, I don't mean testing the amount of the pattern, I mean testing usage of it.
Right. I don't know.
Back to terms.
Okay.
So the purpose of that class is just to hang those watches on something that so that it will super rise up to stream.
Yeah.
If you use a prepend that stream instead, super would then sub. So you wouldn't be all streams would now have watches.
Yeah, probably. Yeah, I think.
Intended by refinements. Selectively.
Yes, I did attend your refinements. Right.
And invert relationships would be like
You wouldn't have to say chatty string include stuff, right? You could just say, hey string, hey string, when you want to do these special watchers, let me know.
Problem is super. Who's pre and super is that. As opposed to this kind of layer. Talk about extended into.
Right.
That way super would actually work stream instead of having to have the giant stream.
That's true.
And you just make all your streams super giant.
Any thoughts, questions? Like, is this something like actually useful? Like, because I think I wouldn't use this a lot, but I think well, actually, I can't show you because it's proprietary company code, but there are 2 places in our code where we're doing this kind of thing, right? It's not showing up all over the place, but we did find a use where it's like, man, that would be really nice to have more flexible type module that would do some stuff for us, huh? Why don't you find it?
Okay. But I always get in trouble with metaprogramming apps that need to be supported by. So
Metaprogramming and what?
apps that need to be supported by teams over time. It's just better in library code.
Because nobody wants to grok.
It's awesome. We know all that.
Look in the active record extend stuff that Jeremy wrote, and you'll see him doing some intro. Actually, I think he refactored it. He might not have this. Yes. I think he just changed his mind on something, but he's doing something very similar. I don't know. The end. Thanks.
Yeah, I think it's interesting. I think including with an instantiation of a class isn't something I've really seen before.
Yeah.
At least not just, it's not wrapped in some DSL of sorts, right? Just straight up doing an instantiation there. Pretty interesting though. I could think like, I get what you're talking about now.
Like this guy?
Next one.
So where I got
This guy.
hung up was just not realizing that builder method only works with extend. It doesn't work with spells otherwise.
Well, this
This wouldn't be available at the class level.
Right. You'd have to define it. Now, if you defined it as a class method, would it?
Yeah. Well, in that case, you have to listen to the input.
Yeah.
And then bring it in as a class method. You can't.
right.
You can't
Extend.
You gotta like. But what you missed was when you switched to brackets. Now we're talking about the stuff. It uses the brackets to then delegate to you. That's effectively how active records migrations work in outside.
Right. They've got their own. I've noticed that they've got their own.
If you look at it, it takes the version brackets against it.
Right.
That's then going to deciding how to actually choose migrations based off the value of that. Essentially.
Right.
That way, that's what it's actually.
So this is. It's a new sexy syntax that's starting to creep into Rails, I think.
Try auto inject.
But it's pretty interesting. I could see like a decent use case for like including an instantiation of a model in a builder program programming, like API code specifically, like let's say I wanted to log every API request in a certain way and have different logic based on
Right.
the method for it. Or
Like
something
I only
that.
want to log certain, like I was doing with my watcher. I only want to log calls to this thing, right? And then it does that.
Yeah.
And I can just say what method or what attribute do I
Right.
want to log, and
Mhm.
it adapts to that, right?
Like logging is just one sort of exec. Actually, use similar thing to Watcher to publish events to
Right.
graph.
Yeah, that's my point. I mean,
Whenever-
throwing it in
just
a
throw it
memory
in
store. Yeah.
Right.
So, the methods you want to listen to in a good way that's not like
Yeah.
website. So, use event listener, passive events, like just like the Watcher set up.
Yeah.
That's where stuff like this, I think, it's more interesting
Yeah.
aspects.
I posted all my slides to the Slack channel if you want to, like, because those of you who have only been doing Ruby for a few months, this is probably a little extra meta, right? So yeah, as I was writing this out, a lot of these things I would just pull up Pry or IRB or whatever and just kind of like run them and like, wait, is this really how it works? And I'd actually type it out. I tried to make all the examples pretty small so you could type it out in a few lines and verify like, hey, this actually works. This is, or you can stop and look at it, stuff like that.
Actually say, hey, why?
I'm like, well, because it does my 2 hashes and it tries to turn them into, like on my inspect. I thought I caught them all, but tries to do an open quote instead of just my hash. So you won't be able to, so watch out for formatting, which is stupid. I just wish it would do what it told me. But if you copy and paste, there might be some weird stuff that got broken because of formatting. But if you type it in, it should work. That's weird, right? Like, it's true, and when I test it out, I'm like, oh, that's true, but I never thought about making calling module.new and having include module.new, right? It gets weird, right?
This class, if there was no invariance model, this class. What is that? That's like, that's a little tricky for just saying. Class. Lowercase class comparator. Saying I'm not defining a constant equals to class dot, and it also keeps comparator as a name. That's class comparator is just syntax. Same is true for lowercase module. Syntax should be comparator equals module.
Well, there's a difference. There is a difference between using the module keyword and inheriting from the module class. Yeah. There's
Well, right, because you're defining that
Right.
module in that namespace in the project, in whatever you want to call your code base, right? And that's what it's doing. Because if you just type module.new Danny or whatever you're calling your module, it's just going to return the instance of that module, but not necessarily register it and make it included in your workspace, right? Like it's no longer like requiring it in the environment, so to speak.
Well, if I'm understanding it correctly, the module keyword, and you give it a name, but it says, hey, when you try to include this, make an instance of this thing, which is kind of the same thing as module.new. Is that like, I'm not sure if they're exactly, I haven't looked to see if they're exactly the same, but it's yeah, like I'd have to play around with it to see if, I know the behavior is the same. I don't know if the actual representation inside Ruby is the exact same, but I know the behavior is identical of this versus this. Like I get the exact same behavior with these two, right? Do you know if they're
So this one, this module keyword, that name pass to representation of the module that gets extension. Whereas on the next slide, this one doesn't get any information about what it is, so it's anonymous. So it won't be named for, it'll just be named anonymously. It'll just have like
yeah.
Whereas the other one, that's what those keywords. It's not that module is a class, and that's why it has that new name. The class is a module. That's why class has that new name. Just classes are specialization.
Yeah, I probably should have done a little bit more research on that particular point just to see what exactly is going on. But yeah, take the code, play around with it. Like you bring up a good, I'm realizing I didn't figure out exactly the mechanics of it. So I'm probably gonna pull open a pry or something tonight and look at it too.
Sometimes some of this stuff that is
Right.
whereas if you want to figure out what the module keyword does, you're really in C code. It's probably but trying to dive deeper on how Ruby is C code takes long. It's really have there's a bunch of special stuff. The reason why your other inheritance works is because you're
I mean, this guy?
now effectively a name that you're initializing. So in the inheritance chain, it's going to show up as the last name, as opposed to an anonymous.
Any other slides you want me to back up to?
So in that same stretch, this is a total like weird question.
Yeah.
Can I inherit from like class Allen, inherit from like less than sign, right? Last name dot new Maxwell just as well, or is that impossible?
No, because So if you, are you saying, can you inherit from the Allen
Yeah,
class?
rather than doing, you know,
He wants to-
multi-table,
he wants to
multi-class
inherit from
inheritance, can I just do single class inheritance, like class Allen less than last name new Maxwell? Does that work too? Does Ruby evaluate that way?
You could, but that wouldn't be what you're expecting, I think. Because you're getting, if you
I'm just
inherit,
wondering, like,
if you
single
inherit from
class,
last
does it work?
name, you get something that's ultimately still inherited from module. And so if you inherit from last name and add, you know, maybe modify the initialize to define yet another method, then you could do that and then include that new thing into something, right? But if you inherit from last name, you're ultimately still getting a module. Is that what you're asking?
Actually,
I'm just
when you
wondering,
inherit from last name, that's a model. So, yeah.
I mean, we could try it out.
Yeah, I'm gonna try that real
Are you?
The class and
like direct
use a
inheritance
module as a
rather than.
base class.
I'm using a module as a base class for a class. That's what last name is, right? Module is my base class. Last name is my inherited class.
Understanding that Ben was asking.
Superclass must be a
But
class.
when you-
No, you can't.
But when you try to inherit from.
Yeah, that's how you try to like talk about. You get away with that crap. And the answer is no.
You're not
No.
inheriting from a class anymore.
That's trying to inherit from an instance, right? And you can't inherit from an instance, right?
But you can't
Well,
directly
struct
inherit from one. but
struct
can
lets you inherit from an instance, kind of.
Right. You can't single class inherit from that.
Right. If your .new returns a class, you can inherit from a .new, but you're not actually inheriting from an instance. You're inheriting from a returned class. What's that? Yeah.
Yeah, didn't work.
Yeah. Any other slides you want me to pull up, chew on for a little bit? Do you want to show us your IRB session and any cool things that you've discovered as we're?
I haven't found anything cool.
Okay.
I just learned that I'm learning on that. Like just some quirky behaviors of types of inheritance.
Yeah. I really recommend looking at these two if you want to like solidify. You know, sometimes you see it in like the same kind of thing in a couple of different ways. If you're still trying to like kind of grok this stuff. These are the other two things that I looked at when I was making this presentation. So, all right. Well, thanks.
Well, thank you.